Hello everyone, in this video I'm going to be talking about atoms and elements. Now atoms are the building blocks of pretty much everything in the universe. And there's a number of models that we use to describe the atom, but the best one is probably the nuclear model. It's the one that most chemistry relies on. So everything that I talk about in this video is going to be based upon what's called the nuclear model of the atom. So let's start by talking about the structure of the atom. Now right in the middle we have something called the nucleus. Now I'm just going to draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just going to draw what this nucleus looks like. Now I've drawn 10 circles very deliberately, and I'm just going to colour in 5 of those for a particular reason. Shade in very quickly, just got 1, 2, 3. We'll just shade that one there, 4, and let's do this one at the top. 5, and I'll explain why I've picked 5 things to shade in. So this central region of an atom is known as the nucleus, and it's found right in the middle. So right in the middle of the atom is the nucleus. Now these red and, if I call them white, circles that I've drawn represent what the nucleus is comprised of. Now these red, I'll just label them down here. So these red ones are known as protons. So the nucleus comprises of protons, and the ones that I've left white are known as neutrons. Now protons and neutrons are different in that the protons have a charge to them. The protons have a positive charge, so we'll put a plus charge next to that. So protons have positive charge, but neutrons, they have no charge. They are neutral. So overall we can say that the nucleus has a positive, so put a big plus here, a big positive charge because of the presence of those protons. But size-wise, the nucleus is actually relatively small when given the rest of the components of the atom. So right in the middle we've got the nucleus containing protons and neutrons. Now the reason why I've drawn 5 of each is because typically there are the same number of protons and neutrons. But when you get different numbers of neutrons, so when you look at particularly when you consider elements and you look at different atoms of the element with different numbers of neutrons compared to the protons, that's when you get something known as an isotope. Now I do have other videos where I mention this in more detail, and I talk about what isotopes are in greater depth, but it's just to be aware of that isotopes have different numbers of neutrons and protons, but typically they would be the same. So in this video we've got 5 protons and 5 neutrons in that central nucleus. Now around the nucleus is something called electrons. I'm just going to draw perhaps not the best circle, but so we're going to draw in some electrons. Now these electrons we're drawing in purple here, we'll have 2 there. And we'll put 4, let's put 4 electrons on this ring here. So notice I've drawn, and it's actually not overly to scale, but these rings that I've drawn are known as shells. And these electrons that move around the nucleus occupy these particular shells. So these that I've drawn in purple, these are what are called electrons. The electrons move around the nucleus, and these electrons are negatively charged. So these have a minus or a negative charge to them. And they're very, very small, but as you can see, they cover quite a lot of space, and they occupy shells around the nucleus. And the shells ultimately help to explain a number of phenomena that we find in chemistry, particularly the chemistry that's covered in the specification at GCSE. Now, the number of protons equals the number of electrons. That is really crucial to say. And we'll put that just up here as a note. So the number of protons equals, and that's really crucial that it equals the number of electrons. So overall, the charge on an atom is, well, neutral. There is no charge because the number of positives that we have in the nucleus from the protons equals the negative, or balances the negative from the electrons. Now, the charge on the electrons is the same size as the charge on the protons, but opposite, and that's really key to make a note of. Now, this means, as I said, the number of protons will always equal the number of electrons in an atom, and it's when you remove or add electrons, that's when we charge that atom, and that's when we become an ion. So, we'll just make a little note. So, when an atom becomes an ion, that's when we either gain or lose electrons. So the atom has no charge, neutral, and when we gain electrons or lose electrons, that's when it becomes an ion, and we say that that structure then has a charge to it. The atom then becomes an ion and is charged. Now, the reason why I've said in this video that we'll talk about atoms and elements is because it's important to note that elements consist of one type of atom only. So we've said that atoms can have different numbers of protons and neutrons and electrons. And if you look at the periodic table, at the top, so each little box, and there's a separate video that I've done on the periodic table, at the very, very top of each box, you find a number, and that gives you the mass number, which tells you the total number of protons and neutrons you find. If you take hydrogen, it's got 1, helium, 4, if we take copper, 63.5, gallium, 70, completely different numbers. So it shows that different atoms have different numbers of protons, neutrons, and electrons. But what is key is that the number of protons in the nucleus decides what type of atom it is, and in that element, in the elements, we find only one type of atom. So, for example, as I've just said, an atom with 1 proton in its nucleus would be hydrogen. An atom with 2 protons would be helium. And if the substance only contains one type of atom, we refer to it as it says at the top, an element. So elements contain one type of atom. So if we look at copper, for example, all we will find are copper atoms. Aluminium will contain just aluminium atoms. Iron would just contain iron atoms. So all the atoms of a particular element have the same number of protons, but different elements have atoms with different numbers of protons. And then we have just some key information about atoms and elements. So we look really, when we're discussing about atoms, at the nuclear model, the idea of a positively charged nucleus in the middle made up of protons and neutrons, and electrons with a negative charge that occupy these shells around that nucleus. Those electrons have a negative charge, and the positive and negative charges balance one another to give a neutral atom. And it's when those electrons are either lost or gained does that atom then become a charged ion. Okay, hope all that helps.